Question number 3. It's a similar question. We want to show that PQ and QR are not congruent. So we'll find distance dpq, dpq 11 minus 4 square plus minus 8 minus 3 square root. This is going to be 7 square minus 8 plus 3, 5 square minus 5 square, 49 plus 25, which is 74. dqr equal 4 minus 7 square minus 3 minus 5 square root minus 2 square minus 8 square. 4 plus 64, 68 square root. 4 minus 3, actually this is 3. 3 square 9. This is going to be 73. Now we have to answer. dpq equal square root 74, not equal to square root 77, which is dqr. Hence dpq not equal to dqr. Hence pq and qr are not congruent. Question number 9. Question number 4. I'll take this is A and this is B point. So then DAB equal x minus 1 square. So I have two options, minus 1 minus x or minus x minus 1. So I went for this one. Plus 9 minus 3 square root. X plus 1 square, 9 minus 3, 6 square root. But DAB is given square root 65. Hence x plus 1 square plus 36, this is 36, equal, okay, I'll write x square, equal to square root 65, mean x plus 1 square plus 6 square equals 65. X square plus 2x plus 1 plus 36 equals 65. X square plus 2x 37, 65. Nine minus 3, not 6 square, 4 square root 65. Then I took the square root out because both are square roots. Let me explain from here. I square this one. X plus 1 square plus 6 square root. This is 65 square. Then I square this one both. Then you will get this answer. But I didn't write that square part. Anybody can think that, okay, I dropped this one because the square root available in both sides. But what really was happened, what I really did, this is squared. I square both sides, and as a result it will become square root 3. Then x square plus 2x minus 48 equals 0. X plus 8, x minus 6 equals 0, x equal minus 8 and x equals 6. But yeah, that's fine. They are two possible values. X are not distance, they are coordinate. Question number 5 also same. Find two possible values for y. So I'll take this is A and B point. DAB equal y minus 7 square. I take y first. Then 2 minus 5 square root. So this is going to be y minus 7 square minus 2 minus 3 square root. Okay, we'll leave it. Now DAB is given 3 square root 10. So I'll write 9 square 10, because when 3 goes to inside it's going to be 3 square, not 9 square, 3 square. When it is come out of 3 square root 3. When 3 goes to inside 3 square. If you want to take 3 square out, it will become 3. So this is 93 square 90. Now y minus 7 square minus 3 square minus 3 square root equal square root 9. Now I square this one both. Then you end up with y minus 7 square plus minus 3 square, which is 9 equal 90. Now I have to simplify. Y square 14y plus 49 plus 9 equal 90. Y square minus 49, 58 minus 90 equal 0. So y square minus 14y minus 32 equals 0. This is y minus 16 and y plus 2 equals 0. Y equals 16, no. Y equal minus 2. Question number 6. After you read this question, we want to show that two lines are parallel first. L1 y equal 2x plus 4. So m equal to gradient equal to L2 is 6x minus 3y minus 9 equals 0. 6x minus 9 equal minus 3y to other side. I rewrite 3y equals 6x minus 9 divided by 3. Y equal 2x minus 3. Then m equal 2. Hence L1 and L2 are parallel as they have same gradient. Now those are two lines, L1 and L2, and there is another line perpendicular to L1 and going to 3, 0. If it is for this is L3. If it's perpendicular to L1, we know it is perpendicular to L2 as well, because L1 and L2 are parallel lines. Now I want to find the equation of L3. Because since I know point, if I know L1 gradient, I can find the perpendicular gradient to L1. Gradient of line perpendicular to L1. Assume this gradient is M3. Now ML1 gradient is 2, ML2 also 2. Now we know ML1 times ML3 has to be minus 1. They are perpendicular. ML1 is 2. 2 times ML3 is minus 1. ML3 is minus 1 over 2. Simply, if this is 2, you know this is minus 1 over 2 gradient. Now we know, but this is our presentation. Now we know a point 3, 0, and we have a gradient in our hand. We know the gradient m is minus half. Then y minus y1 equal m times x minus x1. So y minus 0 equal minus half times x minus 3. So y equal minus half x plus 3 over 2. So this point is not 3, 0. This is 3, 10. And this is going to be 10. And a bit of correction. Y equal minus half x plus 3 over 2 plus 10. This minus 10 I took to the other side. It means y equal minus half x plus 23 over 2. What is the next one? What is, so this is the, we want to find the coordinate. To find this coordinate, I have to solve this. This is y equal 2x plus 4 equation, and this one y equal minus half 23 plus, then I get this point, and L2 and this equation I have to solve to get this point. So first of all I'll take L1 and this L1 and L3. Y equal minus half x plus 23 over 2. Now from here we can see that 2x plus 4 equal minus half x plus 23 over 2. I'll multiply by 2 all the equation. This is going to be multiplied by 2. This is going to be 4x. This is 8, and this half is cancelled out minus x, and 2 is cancelled out plus 23. So 5x equal 23 minus 8. 5x equal 15. X equal 3. So this point is 3 now. I want to find y. From 1, y equal 2 times 3 plus 4. This is 6 plus 4, which is 10. Oh, now actually 310 point is this one now. It is the intersection point. Now this is L1 and L3. And then part C, we want to find uh, now part C. We want to solve L2 y equal 2x minus 3 and L3 y equal minus half x plus 23 over 2. So I'll make equal, then 23 to minus x equal minus half x plus 23 over 2. I multiply by 2 whole equation. This is going to be 4x minus 6. These two are cancelled out. 2 times this is going to be minus 6. This is plus 23. This is going to be 5x equal 29. X equal 29 over 5. So this is 29 over 5. Now I want to find y. From 2, y equal to 29 over 5 minus 3. This is going to be 58 over 5 minus 3. 58 over 15 over 3, which is 3, and 43 over 3. So what I did was L2 equation, this is L3. I solve, make they are equal since y, then multiply by 2 and simplify. And I got x equal 29, 5. Substitute to 2 from 2, y equal then 43 over 3. Now we need to find the shortest distance between L1 and L2. If you look at this distance, it is not the shortest. If you look at this distance, this is not the shortest. The shortest is the perpendicular distance. Now we have the perpendicular distance and we know the coordinates. Now we know how to find the distance. Now D, I'll put PQ. PQ equal, what are the points? 3, 10 and 29 over 5, 43 over 3. This is 5. So dpq equal 3 minus 29 over 5 square plus 10 minus 43 over 5 square. This is going to be 15 minus 29 over 5 square. Then this is 50 minus 43 over 5 square root. So again 3 minus 29 over 5 square, 10 minus 43 over 5 square, and just simplify. and 245 over 25, which is 1 over 5 over 245. And this is 245 over 25. I write like this. Then this is 245 over 5. So I can write 1 over 5 times 245. So what is the learning of this question? The learning of this question, if you to have a two parallel line, and if we have what is the shortest distance, then to find this one you should know that you should have a perpendicular line, and you should know the coordinate of intersections, and then you can find the distance. That distance is the shortest distance.